Hello students, let us solve some more questions from the GATE 2025 question paper. This is question number 44. So this says you have been given a quantum system which has two energy levels. Energy levels are E1 and E2, and the perturbed Hamiltonian is given by H dash lambda sigma x, and sigma x is spin matrix whose value is 0, 1, 1, 0. And now they are asking the first order and second order correction to the E1. Okay, so you want the first and second order correction into the energy of E1 due to this perturbed Hamiltonian. So we know the first order correction and energy level is given by N H N. So I want the correction in the first energy level. So this will be 1 H. Your H is given lambda delta sigma x 1, and now this will be equal to lambda delta 1 sigma x 1. Now this is the matrix element of this matrix, so 1 element is 0, so your E1 correction in E1 will be 0. Okay, now let us write for E2 second order correction. So second order correction in any level is given by En minus Em summation n is not equal to m. Okay, so then you have m h n and mod square. Okay, you have h dash here. So I want correction in the first order. So here only there are two levels. So I can write simply n is not equal to m. So there will be only 2 h dash 1 square. Now En is E1 minus E2. And now this gives me lambda square delta square to matrix element of sigma square E1 minus E2, and the 2 1 element is 1. So this gives me correction lambda square delta square E1 minus E2. Now if you want the magnitude, so you can write lambda square delta square E1 minus E2 magnitude. That's the question magnitude. Okay, so the option A, okay, is the correct answer for this question. Now let us go for the second question. So second question says a system of the three non-identical half-spin particle and the Hamiltonian is given and they want the eigenvalue of the system. Okay, so let us first write the Hamiltonian. So Hamiltonian is your A by h cut square S1 plus S2 dot S3. Okay, so I want this operator. So let us first write the total operator as, so total spin operator. So I can write S is S1 plus S2 plus S3. Okay, and now this S1 plus S2 I can write as a S12 S3. Okay, now I want this value, so I can take the square. So S square will give me S12 square plus S3 square plus 2S12 S3. And now I want S12 S3. So S12 dot S3 will be equal to S square minus S12 square minus S3 square divide by 2. And now my Hamiltonian becomes H upon A upon H cut square. And now this I have already solved. This is S1 plus S2 dot S3. So this is your S square minus S12 square minus S3 square. Okay. Now let us find the eigenvalues. So here S12, okay, S12 is basically S1 plus S2. So this can be 0 and 1. This can be 0 and 1. Okay. And now if I take S, okay, S is what? S is S1 plus 2 plus S3. So if I take S1 equals to 0, then my total S can be only half. Okay, because S3 half. Okay, and now if I take S12 is equal to 1, so in this case my S can be either half, or it can be also, S can be also 3 by 2. So I have total 3 cases. 1, 2, and third case when S12 is 1, S by is to a 3 by 2. Now let us calculate the eigenvalue, put these values here. So I have H. So first case, if I put this value, now A upon 2H square, the eigenvalue of S square operator is S plus 1 minus S12 plus 1 and minus S3 plus 1. These are the eigenvalues of S square operator. Now put these 3 cases you put. If I put S1 to 0, this term becomes 0, S1 half, and S3 is already half. Okay, so S3 is half. So if for first case your H will become 0. For second case what will happen? Second case I will take S1 is equal to 1. Okay, and this is S half. So this become A upon 2H square. This become 3 by 4. H cut square is also there. So 3 by 4 H cut square. This is minus 2, 1 minus 2, and this is also again minus 3.4 H cut square. This cancels out. This gives a minus 2. So this gives me the value 2 this 2 cancels. Okay, H cut square cancels. So this gives me value minus A. And now let us find the third value. If I take S is equal to 3 by 2, in that case, if S is 3 by 2, so this become 2H cut square. So 3 by 2 plus 1, 5 by 2, 5 by 2, and 3 to 15 by 4. This gives me 15 by 4. This is again H cut square. This is 2 H cut square, and this is again same 3 by 4 H cut square. Okay, and if I solve this one, so this is 4, 8, 11, 4. This give me 1 H square. So this will be give me A by 2. Okay, so I have 3 eigenvalues, 0, A by 2, and minus A. So this is the correct answer for this question. Okay, thank you very much. Hope you like the solution.